Welcome to The Explainer. Today, we are completely flipping the script on the chemicals industry. When most of us think of chemical manufacturing, we immediately picture smokestacks, heavy machinery, and, well, just massive energy consumption, right? But today, we're diving into the sector's hidden potential. It's not just about driving global sustainability. It's about generating massive, measurable revenue while doing it. We are talking about a total, fundamental shift in how we actually value chemical products. So, can the chemical industry actually be the ultimate driver of global sustainability? It kind of sounds counterintuitive at first, I know. Historically, chemical manufacturing is an incredibly energy-intensive process. It leans heavily on fossil fuels for processing units and raw feedstocks. But here's the secret. Their R&D labs, they're holding the keys to unlocking massive downstream green tech solutions. We really have to look past the factory floor and focus on what these chemicals actually do out in the real world.
Chapter 1. The Hidden Sustainability Engine.
To understand this engine, we've got to shift our perspective. Instead of seeing sustainability as just a compliance cost, dealing with hazardous waste or capping manufacturing emissions, we need to see the industry's innovations as a massive solution. The absolute crucial concept here is use phase resource efficiency. According to the SASB, the Sustainability Accounting Standards Board, this is all about what a chemical product actually does for the end user's environmental footprint over its entire lifespan. Does it improve energy efficiency? Does it actively lower greenhouse gas emissions? Does it increase product longevity? If the answer is yes, then that product is driving use phase efficiency.
Chapter 2. The Futuristic Design Studio.
Imagine stepping into a sleek, high-tech design studio where invisible chemical components are making highly visible green technology possible. Picture how these hidden molecular designs are literally saving energy and water for downstream customers in their everyday lives. Let's take a seemingly simple product like paint. Chemical companies are engineering high-albedo paints that reflect significantly more sunlight than standard paints. When you apply them to buildings, they drastically reduce cooling needs and overall energy consumption. The chemical company does the innovating, and the downstream customer, like the building owner, reaps these massive energy rewards.
And it's a very similar story with advanced building insulation materials. We're not just talking about that fluffy pink fiberglass anymore. These are highly engineered chemical compounds creating incredibly efficient thermal barriers. By integrating these advanced materials into construction, building developers can massively drop their long-term heating and cooling energy requirements. The chemical innovation sits completely invisibly inside the wall, but the environmental impact, and of course the cost savings for the end consumer, is absolutely huge.
This next example brilliantly illustrates the macro impact of a micro change. Lightweight polymers. The chemicals industry is formulating advanced polymers that are literally strong enough to replace heavy metal parts in cars and aircraft. This directly enables what the industry calls vehicle lightweighting. When a vehicle is lighter, it simply requires less energy to move, which dramatically lowers fuel consumption, saving you money at the pump, and it cuts emissions right there on the road. It is a perfect example of how a chemical product eliminates emissions directly during its use phase.
But beyond building materials and car parts, chemical R&D is the hidden engine powering so much more of the green revolution. We're talking about fuel additives specifically designed for far more efficient combustion. We're looking at additives that simply extend the useful life of a product, meaning way less waste and lower replacement manufacturing over time. And we definitely can't forget renewable energy materials. Think about solar films, solar shingles, and next-generation biofuels. Literally, all of these require cutting-edge chemical engineering before they ever see the light of day.
Chapter 3. Capturing green market share. Because designing for impact isn't just about environmental stewardship. It's about a very real, very lucrative financial paradigm shift. As the SASB standards point out, capturing this green market demand translates directly into increased revenue, stronger competitive positioning, and significantly enhanced brand value. Think about it. As global resource scarcity increases, the demand for these high-efficiency downstream products is going to absolutely skyrocket. By proving that their products reduce emissions, water use, or material consumption for their customers, chemical companies are generating entirely new revenue streams and positioning themselves to capture massive market share.
Chapter 4. Measuring financial impact.
Now, this all sounds great in theory, right? But how exactly do investors track this massive financial upside without falling for greenwashing? Well, they follow the money. Specifically, they use SASB metric RTCH 410A.1. This metric requires companies to disclose the exact revenue derived from products specifically designed for use phase resource efficiency. But the key here, the real secret sauce, is the rigorous qualification process. The reporting criteria outlined by SASB are incredibly strict. To actually count as revenue under the standard, the product must provide a tested, modeled, or proven meaningful improvement. The chemical company must literally prove that the product eliminates a raw material need, drops water consumption, or actively lowers greenhouse gas emissions during its actual use. And what doesn't count? Well, the standard explicitly excludes products that only impart a minimal or ancillary tweak. So if a company just releases a conventional product that's, say, slightly lighter than last year's model, that revenue doesn't count. The improvement has to be deliberate and it has to be significant.
So I'll leave you with this final thought. The next time you look at a cutting-edge electric vehicle, a sprawling solar array, or a LEED-certified skyscraper, will you see the invisible chemical innovations making it all work? As global resource scarcity grows, we have to rethink where sustainability actually starts, because it starts right there in the chemical design studio. How will you track the immense market share these chemical innovators stand to capture in our sustainable future? Thank you for joining me for this explainer, and keep looking for those hidden engines of change.